Welcome students. So in previous class we have discussed about what is radioactivity and the particles emitted from nucleus. These are called radioactive particles. The particles are known as there is two types of particle emitted. One is called alpha, another is beta, and one radiation emitted is called gamma. Okay, and alpha is basically helium nucleus and beta is the electron and gamma is the radiation electromagnetic wave. So today we will discuss the property of these particles and some more things. The property of the particles. Now, alpha particle, I have told that alpha is only helium nucleus. It is 2 neutron and 2 protons, and so alpha particle, we can write the alpha particle as He42. Okay, this is the alpha particle, and the mass of the alpha particle is equal to the 4 times the mass of the proton, roughly 4 times mass of the proton, because mass of neutron is slightly greater than mass of proton. The speed of the alpha particle, speed means when it's coming out from a nucleus, its speed near about 10 to the 7 meter per second. The alpha particle is strongly ionized the gas because it is ionized, positively charged, so it can ionize the gas. Okay, the ionizing power of the alpha particle is roughly 100 times of the beta particle. Okay, and alpha particle rapidly loses its energy because it is heavy particle, so it loses rapidly its energy as it moves through medium, and therefore the penetrating power is quite small. The penetrating power, as it has high mass and also large size than beta, so it has less penetrating power. Its penetrating power roughly 1 by 100 times of the beta particle and 10 to the minus 4 times that of the gamma radiation. These are positive charged, I have told, so they are deflected by electric and magnetic field. They affect the photographic plate and they cause the fluorescence on striking the fluorescent material. They destroy the living cells and cause biological damage. These are the properties. And property of beta particle. Beta particle basically electron. The electron emitted from nucleus. Basically when neutron converted to proton, it may emit electron. Okay, that means electron created. Electron is not available within nucleus, but it created. Okay, so although beta particle is a cathode ray, both fast moving electron, the difference is their origin. Cathode ray and beta particle, they are fast moving electron, but they are different in their origin. But in cathode ray, the electron coming from the outer orbit of atom, but beta particle coming from the nucleus. Okay. The speed of beta particle is order of 10 to the minus 8 meter per second, less than 3 into 10 to 8 meter, because we know the no particle have particle velocity cannot reach near about the speed of light. Beta particle ionize the gas through which they pass. Okay, as it is a charge, basically it is a electron, and the ionizing power roughly 1 by 100 times of the alpha particle. Okay, the penetrating power more than the alpha particle. Beta particle negatively charged. They affect the photographic plate. They causes fluorescence on striking the fluorescent material. The product of X-ray produce X-ray when they are stopped by metals of high atomic number and high melting point such as tungsten. Property of gamma particle. Gamma is not a particle, it is a radiation. Gamma is not a particle, it is a radiation. Okay, it is basically electromagnetic wave, like light ray. Okay, but its frequency is very high, higher than light, and also its wavelength is very small. Okay, and its wavelength is less than the wavelength of the X-ray. We know the X-ray minimum wavelength of the X-ray near about 0.1 Armstrong, and less than 0.1 Armstrong the radiations are called gamma rays. Okay. The speed of gamma rays is same as the speed of light, as it is a electromagnetic wave, and all electromagnetic wave has same speed. The ionizing power of gamma radiation is low because it is not a charged particle, but it can ionize, means it can give energy to electron, and so that electron can escape from the orbit of atom. So it is 10 to the power minus 4 times that the alpha particle and 10 to the power minus 2 times that of the beta particle. The penetrating power is high. It is about 10 to the 4 times that the alpha particle. Okay, it has very high penetrating power. As it has low short wavelength, it can penetrate very large distance. Okay. Like X-ray and light, gamma radiation are not deflected by electric and magnetic field because it is a magnetic electromagnetic wave. It is not a charged particle. They affect the photographic field. They cause the fluorescent and they strike the fluorescent material. Like X-ray, gamma radiation are also difficult and diffracted by crystal. Okay. And distinction between the property of alpha, beta, and gamma radiation. Here all the property are distinction given. You can study. Okay. Change within the nucleus in emission of alpha, beta, and gamma radiations. Okay. So when an alpha particle emitted from a nucleus, then how the nucleus change, and from one nucleus, when an alpha particle emitted from nucleus, then the how it transformed to another element is, these are the changes. Okay. So for alpha emission, if X is a parent nucleus, okay, parent nucleus means from which the alpha particle will emit. Okay, this parent nucleus has mass number, it has mass number A and atomic number Z. When alpha particle emitted from it, then the daughter nucleus formed. The daughter nucleus here is Y. So the total mass number, like molecular reaction, this phenomenon we may say it is a nuclear reaction. In case of nuclear reaction, the mass number of reactants is equals to the mass number of the daughter elements. Okay. So it means the mass number of parent nucleus is equals to the mass number of daughter element, and proton number of parent nucleus will be equal to the proton number of daughter elements, daughter nucleus and alpha particle. When XAZ is a parent nucleus emits alpha particle, then it form another element called Y, and Y have must be the mass number A minus 4 because helium has mass number 4, and Z minus 2 proton number because helium has proton number 2. Okay, so you can see that if we add A minus 4 plus 4 will be A, and Z minus 2 plus 2 will be Z. Okay. In case of beta emission, beta is basically electron. Okay. You can write electron has charge -1 and it is mass is 0 because mass of electron is negligible with respect to proton or neutron. Okay, so beta, for beta emission we can write E -1 0. Okay, so for beta emission mass number does not change, but atomic number Z increases by 1. Okay, and this equation is not correct. When XAZ emits a beta means electron -1 0. Okay, its and daughter nucleus will be the same mass number A, and proton number will increase from Z to Z plus 1. Okay, you can calculate this. Z plus 1 minus 1 will be Z, and A plus 0 will be A. Okay, that means now mass number of parent nucleus and daughter nucleus plus emitted particle will be same, and proton number will be conserved. Okay, this is called for beta. For gamma radiation, gamma is not particle, it is just radiation, means excess energy. When a nucleus after emission of the alpha and beta particle, it may be in excited state, and to get stability or to reach its stable state, it emits some energy in form of radiation. Okay, this radiation is called gamma radiation. Okay, so gamma radiation is no mass, no electric charge, no neutron and proton lost, hence the nucleus does not decay into different nucleus. Either there is no change of the mass nucleus A. Okay, so Here is a note that electron emitted in beta decay does not exist in nucleus. I have told that electron does not exist in nucleus, but they create it. It is created as a result. The decay of one neutron into proton inside the nucleus is instantaneously emitted. Okay. In single radioactive decay, alpha and beta particle never emitted simultaneously. First, there will be either alpha emission or beta emission, which may be accompanied by gamma emission. Gamma emission can occur with the both of alpha and beta emission. And another point is the daughter product formed after the emission of either alpha particle or beta particle may again be radioactive. Okay, then it again, suppose one nucleus first emits alpha particle and convert into another nucleus, and if this daughter nucleus becomes radioactive, then it emits again radioactive alpha or beta. Okay, it may emit alpha or beta. Okay. It may further decay by emitting either alpha or beta particle. This process is continued till a stable nucleus forms. Now we will do one problem. So the question is, an element xaz converted into y a minus 20 z plus 2 through a number of step of decay. Calculate how many number of alpha and beta emitted during whole process. First we have to calculate that the mass number change. Okay, their mass number change from a to a minus 20. Okay, that means due to emission of alpha particle only the mass number will change, otherwise mass number will not change. So first we have to calculate how many number of alpha particle emitted, then we will calculate how many beta particle emitted. So number of alpha particle will be 20 by, we know mass number of alpha is 4, 20 by 4 means 5 number of alpha particle emitted. Then now we have to calculate number of beta. If 5 number of alpha particle emitted means proton number decreased by, when 5 alpha emitted, suppose x a z, that will be y1 a minus 20 and z minus 10 plus 5 alpha will be. Okay, you can calculate this. A minus 20 plus 5 into 4 means a, and z minus 10 plus 5 into 2 equals to z. Okay, so 5 alpha particle emitted first, and now due to the emission of beta the proton number will be changed, means z change. So from z minus 2 to z minus 10 to the particle element changes to from z plus 2, means y1 z minus 2, y1 a minus 20 z minus 10 to, we have to change y a minus 20 z plus 2 plus there will be some beta particle emission. So how many beta particle will emit? Z minus 2 means minus 1, and there will be I think 12. Okay, z plus 2 minus 12 means z minus 10. Okay, means 5 number of alpha particle emitted and beta particle 12 beta particle emitted. Okay, so beta will be 12. These are radioactive emission and the change atomic number and mass number due to radioactive emission. Usage of radioactivity. So radioactive isotopes, medical use. Diseases such as leukemia and cancer are cured by radiation therapy. Radiation from cobalt-60, okay, are used to treat the cancer cell by killing the cell in malignant tumor of the patient. Okay, radioactive radiations can kill the cancer cells of cobalt-60. The salt of weak radioactive isotopes such as sodium chloride, radioactive sodium chloride, and radioiron and radioiodine are used for diagnosis. Such as radioisotope are called tracer. Gamma radiation emitted by radioisotope are used to sterilize bandage, okay, and dressing, searing, and other equipment to make them free of germ. Scientific use. There is many more scientific uses also. Alpha particle emitted from radiation isotopes are used as a projectile for nuclear reactor. The Rutherford gold foil experiment. The Rutherford, he, the alpha particle uh, bomb bombarded the iron plate, the gold plate bombarded by the alpha particle. The alpha particle emitted from radioactive nucleus. Okay, and the age of rock or hence buried plants is estimated by study of the rate of decay C14. Okay, the process is called carbon dating. Industrial usage. Radioactive isotope are used as fuel for atomic energy reactor. Okay. Radioactive is used by engineers in factory to avoid the accumulation of charge in moving part due to friction. Okay. Ionizing effect of radiation from radioactive isotope used to making certain luminescent sign. The thickness of paper, plastic, metal sheet is controlled during manufacture when the penetrating power of beta particle emitted from radioactive isotope is known. Source of harmful radiations. The main source of harmful radiations are radioactive fallout from nuclear power plant, nuclear wastage, and other sources such as cosmic radiation. First is radioactive fallout from nuclear power plant. The nuclear power plant we use radioactive substance, and this radioactive radiation is the very much dangerous. And sometimes the nuclear power plant may blast. Okay. This is very dangerous, and this was happens also. The three such accident already occurred that in USA on 28 March 1979, Ukraine, okay, in USSR means Chernobyl, on 26 April 1986, in Japan 11th March 2011. This accident caused damage of the reactor building and injury to the person working in plant. Okay. Plants. Nuclear wastage. The wastage coming from nucleus they are sometimes radioactive. Okay. And these radioactive nucleus are very much dangerous. And nuclear wastage are basically the lead, because the radioactive element when converted into the stable nucleus, the stable nucleus is the highest radioactive, means highest mass number having which is stable. That's why the lead is very dangerous too, and this is a dangerous wastage also. And other source such as cosmic radiation and X-ray, and the cosmic radiation and X-ray coming from cosmic radiation means the radiations, means gamma radiations or alpha radiations, alpha not like beta radiation coming from sun or other planet or from other star. That contain large number of high energy particle which can be destroyed by the magnetic field of Earth. Earth is a large magnet, and this magnetic field of Earth opposed to enter this cosmic radiation to the Earth's surface. Harmful effect of radiation. There is harmful biological effect in nuclear type. The biological effect, it can change our genetic system, it can change DNA, RNA type. Okay. These are very dangerous. This change the also the not only one generation, it affect generation by generation. Okay. By changing the genetic DNA and RNA. Okay. Short term recoverable effect like diarrhea, sore throat, loss of hair, like that. Safety and precaution while using nuclear energy. We have to take some precaution. That you have to use some apron, through which lead apron, through which the radioactive substance, radioactive radiation cannot penetrate. Safety and measurement while establishing power plant. You have to take some safety. You must, in power plant there is large number of heat produced, and that why we have to cool by using water. and this cooling system will be perfect, because if due to faulty of cooling system, there is large probability to blast the power plant. Okay. Safety measures while handling radioactive material. During handling radioactive, we have to uh, do make sufficient distance from radioactive material. Okay. And they should be put on special lead lined aprons and lead gloves. Okay. They should handle on radioactive material with long lead tons, and many more things we have to read. Thank you.